Well, good afternoon. This is another video in the 435B series. This is zero carryover testing. So my original meter, which is this guy over here, I thought had a hell of a lot of noise on the zero carryover line. And so I went, did a little bit of spelunking in my tower of test gear, and I found that I had two other 435B. So this one is fully working. It's a classic 435B front option. This guy here is an HO4, which is a special build, and the special build was this dial here. It's actually a rear rear input version. And clearly, whoever got it, had to have been made for an actual test jig, some form of production test jig, because you would mount this in the rack, and you would have all the sensors and everything connected to the back. And then they must have wanted very accurate sensor calibrations, because on the if you look at the sensor, let me see if I can put that in. Hopefully that's in focus, because I can only see the very small thing. But you'll see that the calibration factor is at least 0.1, possibly a little more. If you went and looked, I'd have to look at the actual calibration document to see whether or not they provided more decimals. But in any case, the 435s only have at 1% calibration. So by using this, and you might be able to see it right here, you can see that we can move at greater than 0.1% accuracy around the calibration. So that must have been required at some point. And the little tag, it's MTM Inc. And in fact, this one over here is MTM Inc. as well. So the only thing, I don't know who MTM Inc. is. I did a bit of a query, and the only thing that seems to make sense is MTM Scientific, which produces antennas and stuff. But in any case, I managed to pick up 2 meters, I guess, from the auctioning of the same company. So this was the original meter I was looking at, and I wanted to run the zero carryover test, because we'd already tested the power reference, and we've got that all dialed in to nicely be accurate. So there is a test performance for zero carryover, and the spec is plus or minus 0.05% of full scale when zeroed. So let's go do that. Now, because I noticed this was very noisy, what I wanted to do was to try and make sure that I got some idea of what the average, min, max, and the standard deviation was and everything. So what I did is I wrote a little program that will go and capture that information. And now, rather than turning around each time, I'm just going to press enter on my keyboard here. So the first step is to check and see whether or not holding down the zero button on its most sensitive range, if holding down that zero button will get us a meter reading of 0.9, plus or minus 0.9 millivolt DC. So let's take a look at that. That's bouncing around way too much. So let's do where's right. There we go. Let's turn that down to slow, and then we'll press this, and we get 0.1, 0.3, 0.1, 0.3, 0.2. Okay, so I think this is pretty much okay. So let's at least start the process. So now let's run my application. So the app I wrote talks to the Keithley. This is a Keithley 2015 THD. It does a bunch of harmonic work as well. It's actually a pretty good meter. meter is here and as my bench is here, but my computer is on the other side. So I just wrote the little app to work with this keyboard. Well, it works with a keyboard. It's expecting an enter key here, but it's telling me let's go fully counterclockwise and let's hit enter. And now it's going to take 500, I think, samples. And then it will give me the, it'll calculate the min, max, and the standard deviation and average there. And it will also tell me when to step up. So let's go do that. Drink of the day, soda from my soda stream with vodka. It's Platinum 7X. It's made by Seagram's, I think. Anyway, it's made out of Louisiana. I think it's in New Orleans. So very good vodka, very inexpensive prices. Okay, so let's step up one range and we'll kick off the next set of value catches. Now, as the app is basically triggering a 500 count sample and then putting that in a buffer and then waiting for the SRQ to be asserted. When the SRQ is asserted, it grabs that data and returns it and does some calculations. So that means that we could actually leave this running longer, but there's only 1,000 measurement buffer, I think, in the 2015. So we're sort of limited. We could slow it down. We could put a triggered delay in, but this should give us enough data to be able to decide whether or not zero carryover is good. Okay, now we should be the last step. There we go. Okay, there we go, and we're back to normal. So this will have produced a PDF file, and we'll take a look at that in a second. I'm just actually going to open it up now just to see what we see. And everything passed there. So let's swap over to this middle meter here. So there we are. Let's step that right down again. Gonna have a little bit more vodka soda. Okay. So let's push the, oh, it helps if I actually plug the sensor in. So there we go, let's plug that in. 1,000, 2,000, 3,000, 4,000, 5,000. This auto zero circuit, they say in the manual, can take up to 5 seconds to fully zero. So, you know, just gonna hold it in. We're pretty much below 0.9 of a millivolt. All right, so let's make sure we're set there. And then let's run our app again. I need to, okay, fully clockwise. All right, let's grab that. This is riveting video here, but you know, we're going through the process again to test each meter. We can't test this one because, as you can see, this has been scavenged and stuff has gone on here. What I need to do though is to print more of the rings that can are the range rings. Basically, you take off here, you take off this little cap, and you can see the cap here. We'll wait until this finishes and then we'll go to our next range. And then these rings will mount on here, and there's a bunch of different ones. And they'll actually all sit there. They're also stored there, that are designed to work with the various 84 8X power sensors. So you can have the right display, you know, here in terms of the power you're reading based on the sensor that you're actually using. I need to print some more of those so that, and laminate them or something so that I can put them on this machine here. Okay, now that we have those two files done, let's just print those out and take a look at them. Okay, well, here we go. This is for this meter here. We can see that it passed on average, and it passed on, if we look down here, it passed on the maxes there as well. So this meter seems to be working well. This was the one that I was having a bit of issue with in terms of the noise that was involved in it. If you look, it's also passed, but it has like quite a bit of noise range there between the two mins and maxes. It still is under the results, but it is way noisier than this meter is here. So at least what we're seeing is that these values here are in fact, pass. So that is telling me that the meter's good to move on to the next step, which is actually to look at the range accuracy. Anyway, I hope you found that interesting. I will catch you again in the next video. Thanks very much.